How about, let's go now to the 9 ohm. What is the current in the 9 ohm resistor? When this 0.7 comes here, it will split into one part going through 7 ohm, the other part going through 10 ohm. They will combine and will become 0.7 ampere in the 9 ohm. So the current in the 9 ohm resistor is 0.7 ampere. So can you find the potential difference across the 9 ohm? Alright, the potential difference across the 9 ohm is V equal to IR, I equal to 0.7 ampere, resistance equal to 9 ohm, therefore that is 6.3 volt. Now, can you find these two in order to obtain the potential difference across these two resistors? We have obtained the potential difference across the 4 ohm as 2.8 volt. We found the potential difference across the 9 ohm. It is 6.3 volt. Now, what is the total potential difference between this 4 ohm and the 9 ohm? It is 2.8 plus 6.3, that is 9.1 volt. What is the total potential? The total potential is 12 volt. And out of that 12 volt, 2.8 is across the 4 ohm, 6.3 is across the 9 ohm, a total of 9.1 volt has been used up. What is the remaining? The remaining potential is 12 minus 9.1, and that will be the potential difference you will see across the parallel combination. And you know that if resistors are in parallel, they will have the same potential difference across them. So this 2.9 volt, which is the leftover, will appear across each of these resistors. So the potential drop across the parallel combination is 2.9 volt. That means the potential difference across the 7 ohm is 2.9 volt, and the potential difference across the 10 ohm is also 2.9 volt. And we can use that now to find the current in the 7 ohm. Can you do that? We know the resistance is 7 ohm. We know the potential difference across the 7 ohm is 2.9 volt. Can you find the current in it? The current in the 7 ohm is I equal to V over R. V, the potential difference across the 7 ohm is 2.9 volt, and the resistance is 7 ohm. So the current is 2.9 divided by 7, that is 0.41 ampere. Alright, so 0.41 ampere is the current in 7 ohm. And the potential difference across the 10 ohm also is 2.9 volt. Can you calculate the current in it? The current in the 10 ohm is potential difference divided by the resistance. The potential difference across the 10 ohm is 2.9 volt. Resistance is 10 ohm. So that will be 2.9 divided by 10. That is 0.29. So the current in the 10 ohm is 0.29. Now look at this. What do you get if you add these two? What is 0.41 added to 0.29? That is the total current, 0.7. So that works out very well. When the 0.7 ampere comes here, it divides into 0.41 on the 7 ohm, 0.29 on the 10 ohm. They will both combine here to become 0.7, the total current. So now we have obtained the potential difference across each resistor, and we also have the current in each resistor. A very important type of problem. You see, what all we did is to use Ohm's law in solving this problem. Alright, let's do another one. A battery has an EMF E and an internal resistance R. When a 5 ohm resistor is connected across the terminals, the current is 0.5 ampere. when this resistor is replaced by an 11 ohm resistor, the current is 0.25 ampere. Find E and R. Find the EMF and the internal resistance of the cell. Alright, remember, any problem like this can be done only if you know how to represent the problem by using a circuit diagram. Now, what is the circuit diagram like here? A battery has an EMF E and an internal resistance R, and a 5 ohm resistor is connected across the terminals. A current 0.5 ampere flows in it. Alright, here we have a battery. The EMF is E and the internal resistance is R. Now, you know how we represent the internal resistance. This stands for the resistance offered by the cell for the flow of current. So we have a battery of EMF E and internal resistance R. When R equal to 5 ohm and that battery is connected across an external resistance of 5 ohm. And what is the current? The current is 0.5 ampere. Okay. Can you write an equation connecting all this? We have EMF E, the current in the circuit, we have the total resistance in the circuit. What is the total resistance now? The external resistance is 5 ohm, the internal resistance is small r, so the total resistance is 5 plus r. The equation for the whole circuit is, if you remember, E equal to I times R plus R. That is the equation for the whole circuit. So E equal to I times R plus R. Now use the values there. You got E equal to 0.5, that's the current, times external resistance is 5, and we don't know the internal resistance. We have an equation that contains two unknowns. We cannot solve it. We need another equation. Now, we can find another equation using the scenario given here. What is that? When this 5 ohm is replaced by this 11 ohm, so the external resistor, this is now replaced by an 11 ohm, the current now becomes 0.25. Let's go and make that change. When R equal to 11 ohm, this resistance now is 11 ohm, the current now is 0.25 ampere. Alright, write the same equation for this setup. What is that equation? Again, E equal to I times big R plus small r. The current now is 0.25. The external resistance is 11 and internal resistance is small r. So, we have now two equations. This is the equation for the first circuit, E equal to 0.5 times 5 plus R, and this is the equation for the second circuit. Now, both equations uses the same cell. That means E is the same for both. So what do we do in this case? At the left-hand sides of these equations are the same, namely E, we can equate the right-hand sides. So the right-hand side of equation 1 is 0.5 times 5 plus R, and that should be equal to the right-hand side of this equation, 0.25 times 11 plus R. I can now leave this for you to solve. Well, simplify the distribute. 0.5 times 5 is 2.5 plus 0.5R is 0.25 times 11 is 2.75 plus 0.25R. And now rearrange the equation. That gives me 0.25R equal to 0.25, or it gives me the internal resistance small r equal to 1 ohm. And to find the EMF, you can now take the value of E to this equation. E equal to 0.5 times 5 plus R. replace this small r by 1 ohm, and that gives you the value of the EMF as 3 volts. That means the cell we used has an EMF of 3 volts and an internal resistance of 1 ohm. Again, a very important type of problem that you should be able to do. Alright, let's do another example. If the potential difference between A and B in the figure here is 120 volt, find the current in each resistor. Actually, this is a similar problem to the one we did previously. We know the potential difference, the total potential difference, and we can therefore find the current in each resistor. Alright, how do we do that? First, find the resistance of the parallel combination. The equivalent resistance of 100 ohm and 50 ohm. Can you do that mentally? The total resistance of these two resistors in parallel will be 100 times 50 divided by 100 plus 50. Yes, and that's equal to 33.3 ohm. So we have now a 100 ohm connected in series with a 33.3 ohm. So the total resistance of 100 and 33.3 ohm in series now is 133.3 ohm. That is now the total resistance here. And the total potential is 120 volts. Therefore, what is the total current? Total current I is V over R. By now, these things must be part of your system. Total potential is 120 volts. Total resistance is 133.3 ohm. And therefore, the current is 0.9 ampere. That is the total current. That means the total current, if you got the power supply here, the total current comes from the battery. It goes through 100 ohm. That means the current in the 100 ohm will be 0.9. But when it comes to this point, it divides into one part on 100 ohm, the other part to the 50 ohm. We need to find those. Alright, so the current in the 100 ohm is 0.9 ampere, which is the total current. The potential difference, therefore, across the 100 ohm. What is the potential difference across the 100 ohm? The current in it is 0.9 ampere. Therefore, the potential difference across that 100 ohm is V equal to Ri. That will be 100 times 0.9. That is 90 volt. Alright, tell me, what is the total potential